Hello everyone. Coming back to the series on cloud architecture and patterns, my first post or video was on Azure and this one is in AWS. So the brief about me and the series deliverables and the disclaimer are all the same. So I still like to focus on the disclaimer before we move on to the next steps or the next slides is whenever possible we'll revert to the official Microsoft or Amazon or Google documentation, as obviously there is no place which is better, no documentation which is better or more authentic information, and there is no point in me redrawing or redocumenting information which is already available in the internet, as the focus of this series is on understanding the concepts rather than like a step-by-step tutorial, because there are already multiple documents which are already available in the internet on those kind of things. So what is the problem statement that we want to focus now? So as I told you that this particular series is much more focused on enterprise architecture. Now in an enterprise you will see that there is very unlikely that there will be only one AWS account. There will be mostly around 50 to 100 or even more than 100 AWS accounts. Enterprises typically segregate their business units with accounts. For example, they will have one account, one structure might be they will have one account for every business unit like sales, finance, operations, HR, manufacturing, retail, or they will have one AWS account for every single project. Meaning, say there is a project 1 to create, for example, some sort of a sales data processing in via an AWS data processing pipeline. So it will be one project. There might be another project for website hosting, that will be another project. Even within projects, it's very likely that the enterprises will want to segregate their AWS accounts based on the environment, meaning one AWS account for dev, one AWS account for QA or prod or whatever, or very likely one for prod, one for non-prod. So it is very likely that in most enterprises you will see a lot of AWS accounts. Now say most of these structures, what happens is that there is one master account which is a main account from where the billing of all those accounts are maintained, and then there are a lot of child accounts. So many times what happens is that we need to run some sort of an operation on every single account and get a report or fetch a data or do some operation. For example, say I want an inventory of all AWS EC2 instances across all my accounts. So manually, normally what I will have to do, I will log into each of these AWS accounts using my credentials, get a list of all my AWS EC2 instances, push them into an Excel, again do the same for another account. So if I have 100 accounts, it will take me days or weeks, or sometimes for very complicated stuff even months. Now obviously most of us, we know how to programmatically access AWS and perform automation. So for example, if I asked a programmer or a cloud engineer, can you get me the list of EC2 instances in your account? They will log in with their credentials via AWS CLI or any AWS PowerShell or something, and they will fetch the list of all your EC2 instances, but within the scope of that account. If I ask the same developer to do it for 5 to 10 or 100 accounts, it is not always that straightforward, because the user, the IAM user mostly is a concept which is at an account level. So my one AWS account will have one AWS IAM user, another will have another user, and even if I have something like an Azure AD federated authentication via Azure AD, still it is quite difficult to use those kind of concepts in your programmatic code. So in this case, what is my problem statement? I have 100 AWS accounts which are managed by me or by my team. I need to prepare reports. For example, prepare an IP capacity report, or prepare a backup report, backup status report, or prepare a CMDB report, or fetch some sort of a data. For example, how many elastic IPs are unused across all my AWS accounts, or perform some operation, but the same operation. For example, I want to start all my VMs across all my AWS accounts at the same time every day at 7 p.m. programmatically on all AWS accounts in an automated way to save time, money, and perform it efficiently. How to achieve this in an efficient, automated, enterprise or scalable manner, which is very important. So the solution in this case is to use cross-account AWS IAM roles and then subsequently to assume those roles to perform the requested activity. Now, like always, we will go to we were going to AWS documentation to go over the process, and in this case actually I have implemented this process also for a few of my clients, and we have some sort of a sample code which is completely generic and based on this document, no client specific code that we can leverage or we can go through. Okay, very good. So let's go through the block. So what they are saying, as a company's adoption of AWS grows, most customers adopt a multi-account strategy. Like I said, some customers choose to create an account for each application while others create an account for each business unit or environment, development, testing, production. Whatever the strategy, there is often a use case that requires access to multiple accounts as well. This post examines cross-account access and the assume role API known as use STS role in Windows PowerShell. This concept I will explain a little bit later. A role, you obviously know an AWS IAM role, it consists of a set of permissions which grant access to actions or resources in AWS. An application uses a role by calling the assume role API function. This function will return a set of temporary credentials that the application can then use in subsequent function calls. Cross-account roles will allow an application in one account to assume a role and act on resources in another account. Again, going forward, we are going to display. So, for example, one common use case for cross-account access is maintaining a configuration management database or CMDB. So, most large enterprise customers have requirement that all servers, including EC2 instances, must be tracked in the CMDB. It is a very good use case. So CMDB, for example, in ServiceNow, for billing purposes and overall cataloging purposes, most enterprises maintain all their configuration items, including servers, databases in the CMDB. So say in this, as it is showing, so we have a pair account which is kind of like the master account with this ID, and it has 3 linked accounts: development, testing and production. As you can see, all of them have separate EC2 instances. So right now there are 3, it can be 300 or 3000 even, which are linked to this pair account. Now what is my task? My task is to get a list of all EC2 instances across this account: development account, production account and testing account. But I don't want to log into each of them individually to get the data. I want to do some sort of an automation so that if I write some sort of a script while running in the pair account, that script can transparently and seamlessly log into each of the account, get the data, push it into some sort of a storage, and finally when it traverses all the accounts, get the total data, consolidated data, and dump it in an Excel or a report or some sort of a data store. So in this case, if you see that there are multiple accounts which are owned by a single customer. Now please note that this linked account concept is not important for cross account access. So even if the pair account was not linked with these 3 accounts, still we could use any account. Even I can use development account or testing account or production account to run my code or to run my script and traverse each of the accounts. So that is what is written, that linked accounts are not required to use cross account roles. They're often used together. You can use cross account roles to access accounts that are not part of a consolidated billing relationship, or even between accounts which are owned by different companies. So cross account roles has nothing to do with linked accounts. They are mostly used together because in an enterprise you will see that the billing and some governance is mostly done from a master account layer or a pair account layer, and all the child accounts are under the umbrella of the master account for governance, billing and a lot of management, simplicity and ease of use. So scenario. So in this case you will see that Bob, a Windows administrator at the company, is tasked with maintaining an inventory of all the instances in each account, right? So this is here, the request is to maintain an inventory. It can be for any sort of report, for example, to fetch a report of the unused IP spaces, what IP space or IP number of IPs are free in each subnet across all the accounts. It can be to fetch a report of all unused elastic IPs on every account. It can be to start a VM or stop a VM or take a backup of all EC2 instances across all accounts. So your use case is very simple. You have to do some sort of a task which normally you do for one account, but in this case you need to do it for n number of accounts, where n is a large number. Now specifically he needs to list EC2 instances. He plans to create a PowerShell script. In this case, this concept is not for PowerShell. It can be done using Python, Boto3 or normal AWS CLI or any SDK. The concept is what is important. The implementation is just, for example, a detail that we don't want to get into. So what we are going to do, one thing he can do, Bob can create one IAM user in each account, hardcode the credentials in the script. But in this case, what will happen? He will have to run the script for each and every account. So the script will basically run for account 1, get the data, store it somewhere, again run for account 2, get the data, stored somewhere. But your entire code is running for each of the accounts. It is not maintainable. Tomorrow you can have another 200 accounts. You will again have to customize your code, right? Also it is not secure. It is also not secure because you are having to hard code all the credentials for each and every account. So basically you are actually doing the automation but for one account only, and then doing it again and again and again for every single account. No, we want an automation which will run from the context of one account, and it will very seamlessly traverse all of these accounts and get me the data. So this is what we want to do. So now I will tell you the concept. So what we will do is that we will, for example, run the script from one VM or from one compute instance, which basically corresponds to my main account, which is the pair account. Now what the pair account will do? The pair account, or the user or the code or the context which is running in the context of the pair account, will assume a single role in each of the account. So for example, if I have 3 or 300 accounts, I will create the same role in all the 300 accounts, and in that role I will mention that this role can be assumed by my pair account. So my pair account or the context which is running in the pair account will basically have the permission to assume the role in each of the accounts. Now what will be the permission for the role? The role is in its own account, and the permission is also the same for all the roles in all the accounts. This permission will be based on the principle of least privilege, right? And the principle of least privilege, what does it say? That I will give the child role in my child account only the privilege that it needs. Meaning, if my duty is to get a list of EC2 instances in each of the child accounts, the child role in my child account will only have read-only permission. So my role in the pair account, my user in the pair account, or my context in the pair account, or my instance profile in the pair account has the permission to only assume the role in the child account. Now once it assumes the role, it is as if that it is in the child account. Now it will get all the permissions and policies that the child account role has. So if the child account role has read-only permission, now my pair account context has that read-only permission. So using those permission, it can do its activity in that account and then get out of that account, then again go to the next account and then again get out of that account. So this is the concept. So if you see, so start, and it is using the STS role to assume the role, basically STS. Then it is assuming the role, which is basically it is doing for each account. So for every account it is trying to do it. So if you see here, for each account, meaning for every account the loop is going, first it will go to account 1 or account 11111, then within that account 1 it will traverse for each region US East 1, US East 2, because all of this AWS API calls are region dependent. So you have to give the region as a parameter. So first you will loop over account 1, then over account 2, then over account 3, and for each account you will loop over region 1, region 2, region 3, and so on. Now when you go to for one account for one region, you have already assumed the role, right? So using that role, which is the same role, you perform the task in the context of that role. Meaning when you are doing get EC2 instance, it will give you the instances for the account where you are in, meaning the child account, and for the region you are in. After that, all the data you will accumulate and you will get out of this loop and you will push that data. So in this concept, you have to basically create a few IAM roles, right? Now, for example, if you see here what is happening. So in each of the client or the child accounts, you create this role which you called cross-account role. Meaning this is the role which is the same role which is in all of these accounts. This role will have the policy which is as per the requirement for a case-to-case basis. So if in each of these accounts you simply need the list of EC2 instances, then you can attach a read-only role. If you need, for example, to perform some activity like start or stop, you can create a custom policy and you can basically attach that custom policy to this role. So this role is only in the context of this account. But what? When you are creating this role, you will mention that this role can be assumed by this Amazon EC2 role, which is the CMDB application role. Now this CMDB application role has the privileges to assume all of these roles, and these child roles have that defined that they can only be assumed by this Amazon EC2 role. Now this security layer is very important. Why we will do this, I will also show the roles later on. So in this case, what will happen is that this role basically will go over, traverse each of these child accounts or the linked accounts. In this case it is linked, without linked also it will work, the child accounts, and then get the data. Now you will see that Bob has created two roles in the pair account, CMDB application and CMDB discovery. So this CMDB discovery is normally the role which is basically the role which is the child role, meaning the role in all the child or the business accounts where you actually want to fetch the data. So why are we adding it even in the main paired account? So the paired account normally will not even have any workload. It is just from a governance or management perspective. Then why are you adding? This is just for ease of use, so that my code can be the same. So my code will treat each of these accounts just like the same. Only thing that in this account, when it will assume the cross account role, maybe there is no instances or any workloads in this account, but still the concept is the same. So that is what is mentioned here. You may be asking why it needs a cross account role in the same account as the application. Creating the CMDB discovery role in every account makes the code easier to write because all accounts are treated the same. So in this case, Bob can treat the pair account just like any of the other accounts without a special code branch. Now see, this CMDB application role. Now normally what happens is that if you are running the script, okay, the main script which is going to do your work in an AWS EC2 instance. So you can run it in an AWS EC2 instance, which is one of the use cases, but a lot of the use cases is that all of these scripts are run from a jump box. In an enterprise machine, most of the scripts are run from a centralized jump box or a toolbox. Now that centralized toolbox might not be in AWS. So in that case, you cannot directly use the role and assign it to the EC2 instance. What you have to do, the concept is very similar. You create an AWS IAM user, you attach the same policy of the role or attach the same role to that IAM user, you create an access key and secret key of that user, and then use that in your account. So that is the main concept. So right now what is happening is that in case we are running it from a toolbox or a jump box or a EC2 instance which is in the AWS EC2, then we can use an instance profile. So we don't need to hard code the access key ID and the secret key in our code, because when the code is running it will use the context of the instance profile or the role which is attached to the EC2 instance. But in case, it's a very possible case where your script is running from a jump box, okay, so in that case, which is not in AWS EC2, then you will have to use the access key and secret key to basically run the to at least get into the context of the pair account. So here you can see what they are saying, that Bob will first create the first Amazon EC2 role, which is the CMDB application in the pair account. This role will be used by the EC2 instance which runs the PowerShell script. So either the EC2 instance which runs the PowerShell script, but if you are running it not from an EC2 instance, then what we will do, we will create an IAM user, then attach this role to the IAM user, create an access key and secret key, and use that access key and secret key to run the script from any compute environment. Now Bob signs into the AWS management console for the pair account and then creates this custom role. So you can see what this custom role is giving. This custom role is giving the EC2 instance or the script which is running this the permission to assume roles, and only that. So this script does not give any other permission. This script is following the principle of least privilege. This script is the permission to assume the role, and on assuming the role you get the permissions of the assumed role. Now the assumed role has a little bit more permission. So as you can see, the CMDB application role grants a single permission, which is the assume role, which allows this application or the script. So think of the application as the script. It can be a PowerShell, Python, Java, C#, whatever, to call the assume role API to get the temporary credentials for the other account. Once it gets the temporary credential, it will use the credentials of that account basically to get the permissions for the assumed role. Notice that Bob is following the best practice of least privileges and assigned only one permission to this application. So this application does not need any other permission. It is only good if it can assume the role, because as soon as it assumes the role, it will inherit or it will get the context or the permissions of the assumed role, which will give him everything that it needs to work in the child account or in the linked account or in the other accounts, business accounts. Now Bob will create a cross-account role which is called CMDB Discovery in each of the accounts, including the paired account. This role will be used to list the EC2 instances in this account. Bob signs into the console for the account and it creates an IAM role for cross-account access. Okay, this is very important. So in this case, they are saying that this role will have the permission to list the EC2 instance, but this is for this case because they are creating a CMDB application discovery application. If you are doing something else, for example, you want to create AWS AMIs for each of the child accounts or each of the business accounts, in this case you will give this role, this child role or this business account role, which will be assumed by the main pair role, to do the activities within this account. For example, to create AMIs, to delete AMIs, create snapshots, and so on. So this is where you will do the change. So the main account role that we have shown earlier, it will always stay the same. It will only assume the role in each of the child accounts. In each of the child accounts, obviously all of the child accounts will have the same role, same name, same kind of permissions, but it will basically be different from case to case. One role will be maybe for stop start, one will be for read only, one will be for create AMI, maybe anything else. Now as you can see, when creating a role there are two options. One provides access between accounts you own and the other provides access from a third party account. Third party account will include an external ID which is outside the scope of this article. This is something else. So external ID, the third party account or AWS partner account. In this case, Bob owns both the accounts, right? So you don't need to think about this issue. So here you think that all of these accounts are under the same organization. Bob simply wants to traverse him, he wants to automate, he wants to do it very seamlessly, so that even if tomorrow there are 200 new accounts, it doesn't have to change a lot. So you can see this role, which is a child role, it is being given EC2 : describe instances, meaning this role will only allow to list my instances, which is good enough for this case, which is a CMDB. If you needed something else, some more powerful role, like for example you wanted to create AMI or create EBS snapshots and stop start VMs, then you will give a little bit more power or more juice to this role. Now this role will be assumed by the main script or the application for each of the accounts, and as soon as it accepts or goes into the context or assumes this role, it will get all the permissions which is in this role. So in this case, the context will, as soon as it assumes this role, it will get the permission to describe all instances within the context of that account within which it has assumed the role. So this is very important. Now again, this policy follows the best practice of least privileges and assigns a single permission which allows the caller to list the EC2 instances in the account. Now see, so with the IAM roles have been created, so mostly everything is okay. Now this instance will use the CMDB application role when the instance is ready. So now it is going to, for example, the actual PowerShell script. Now this is very important. So here also I will explain what is the PowerShell script is doing, and I will show you a working PowerShell script also that we have written for one of our clients. So for example, even before you go here, you will first see this. Okay, so what is this? So here, as I told you, we have a lot of AWS accounts, right? So here there are 4, it can be 400, 4000, whatever. So what they are doing is they are listing down all the AWS accounts here as an array. So one of the other things you can do, which I particularly personally like, is that rather than keeping it an array, because if you keep it an array, tomorrow if you add another 200 accounts, you have to come into this array and change the code or edit the code. But I want a system where I don't have to change any code. So you can actually maintain, for example, all your account ID and account name, okay, in a separate file. So similar concept, rather than reading from the array, you simply read from the file. So you have one account, child account 1, another account, child account 2, another account, child account 3. So tomorrow if you have another account, for example, say 666666666, comma child account 4, you simply add here and you don't have to do a lot anything else. I will tell you what you have to do, maybe 1 or 2 small other things, but normally you don't have to touch the code. Now what it is doing, as soon as it is doing, it is trying to iterate over each account. Good. Now it is trying to create basically your account role name that it wants to assure. So as I told you, this is very important. All of your roles in each of the child accounts needs to have the exact same name. So in this case, CMDB Discovery, as you saw, if you see here, you will see that all of these accounts have the same role, CMDB Discovery, CMDB Discovery, CMDB Discovery. That is why when you want to assume a role, okay, you have to give the role ARN. Okay, it is very important that you have to give the role ARN. So how will you find the role ARN? You will have to create it. So this is the standard. So here in $account, you are getting the account ID. So for example, you will see that this is a sample ARN. So for the first one, what will happen? For your first use case, your role ARN will actually become something like this, which is the actual resource identifier, Amazon resource name for the role. For the second account, the role ARN will become something like this. So as and when it is iterating, the code is iterating over each of the account, it is creating this role ARN, okay, which is different obviously, but the only difference part is the account ID. The role name is always the same, which is very important in this case. So after that, what it is doing, see, it is trying to request basically temporary credentials for each account and creating a credential object. So this is where it gets interesting. It is going into each of the account, it has found the role ARN. Now it will try to assume this role. Now as you know, this role has already allowed, this is already allowed to be assumed by the main account. That is why this role can be assumed, and as soon as you assume this role will give you the context basically to read all your EC2 instances in this case. So if you see use STS role, you have to give the region. That is why you can also basically this is the region where you are calling this use STS role. So this is always US East 1. You don't have to loop over each of the regions. So this kind of use STS role API, all of these APIs, obviously they ask for a region, but actually the region is always US East 1. You don't have to think about the region. This role ARN is the role you are wanting to assume. So this is always different for each account. And then this is something that you have to give called role session name. I will explain later maybe if needed. And then out of this you are getting these credentials, right? So response, what it will do, this code will basically assume the role of in the child account, and it will generate temporary credential, temporary access key ID, temporary secret key. Now using this temporary access key and secret key, like you see in the response.access key ID, response.secret key ID and response.session token, now using this you can actually create a credential. As soon as you get this credential, what is this credential? This credential gives you the permission in the child account to list all EC2 instances. So till this point you were in the context of the parent account or the pair account, but as soon as you get these temporary credentials are giving you access or giving you the context to run your code or to run your script in the context of the child account. So then as soon as you get this context, you iterate over all regions, because your list instances or any business function, for example create AMIs, get IP capacity, whatever, is basically a region dependent. So your EC2 instances APIs will need a region identifier, which will be for example US East 1, then AP Southeast 1 and so on. So you are going to calling this list instances credentials. With this credential, which is the temporary credential, obviously the account, which is this account, which is the account where you are in, which you are wanting to assume, and then the region. So this will iterate over all the regions. Now this list instances, in this case it is doing very simple thing. It is basically listing all the instances in the region. So very simple. It is basically calling this get hyphen EC2 instance using this credential, which is the temporary credentials that I have received by assuming the role, and the region, getting the instances, looping over it, and then adding it to, for example, this PS object, and then getting the value and returning it. Okay, so what happening here is very important, is that this function list instances will change based on your business case. In this case we are doing a CMDB discovery, that is why we are doing list instances. In some other case we might do get AWS AMI snapshots, or for example stop start VMs, or example create AMIs, or whatever. So this use case will change, and based on this code will change, but these parameters will always stay the same: the credential, account and region. As soon as you have these three, you can run any sort of custom business script or business logic in your child function. Okay, very good. Now as soon as this is done, so you have to understand that finally they are converting it to CSV and getting a report. So this report is getting the data of all the AWS accounts and not just one account. So here they are briefly describing what this does. This use STS role retrieves the temporary credential for the IAM role, which is specified in the ARN parameter. The ARN uses the following format, where the role name is the role you created in the target account number, meaning the target account, in this case CMDB Discovery. So that is how it is doing. So the target account number is the target account where, or the child account where you want to assume the role, and the role name is the role you had initially created. This is a manual step that you have to do for each of the 400 accounts. You have to go there and create this role with the same permission, which is the permission that is enough for the business use case that you want to do in that account. Now use STS role will return an access key, a secret key and a session token, which can be used to access the account which is specified in the ARN. So this access key and secret key, the permission context or the boundary is the account, because you are assuming the role which is in the context of that account. So this will not give you the permission for any other account, it will only give you the permission for that account, which is enough, because you want to be in the context of that account to fetch the data, store it in a data store, then go to the next account, then again fetch the data, store it in a data store, and so on. So that's all there is to it. Bob creates a scheduled task which executes the script each night and then sends the result to the CMDB team. When the company adds additional account, Bob simply adds the CMDB Discovery role to the new account and he updates the account list in his script. So this is very important. So this is where the magic and the scalability of this script is coming into place. So for example, tomorrow I have another 5 or 500 accounts. I simply go here and I add here. My code will automatically start iterating over these new accounts also. But another thing is that the role, the same role that I need in all my child accounts or business account, that role needs to be there. That role will have the same permission that is enough for the action that I want to perform there. So what they are saying is that in summary, cross-account roles are a valuable tool for enterprise customers with multiple accounts. The roles will provide temporary credential that a user or application in one account can use to access resources in another account. These temporary credentials do not need to be stored or rotated, resulting in a very secure and maintainable architecture. Okay, so this is what is important. So the architecture is secure and maintainable, and this is what also is very important, this Amazon EC2 role and this context where it is first assuming the role, and based on the assumed role it is then doing the activity for each account and each region. Now let me try to show you a much better implementation of this whole thing. Now in this case what is happening is that I am again doing the same concept where you can see all my accounts I have mentioned in this CSV file. So rather than the array, what I am doing is very same type of concept, is that I am doing a import CSV, and when I am importing the CSV, which is this path, okay, I am getting the account ID and the account name. So you can see account ID and account name. Similarly in a role ARN I am putting this account ID, and here this is where you put the name of the role. This is the role name which you need to use everywhere. Okay, now this is the role which you will create in each of the child accounts, and even if you want in the main account. Okay, no problem with that. Now as you can see, as I am doing the role, then I am getting the response, and then using the response access key ID and secret key ID I am getting the credential. I am iterating over the AWS regions, and then I am calling my function. So here earlier you were calling the get EC2 instance detail for your get CMDB discovery. For example, in this case what I am trying to do is getting the IP capacity. So what this function will do, similar concept, it is taking the credential, account ID and region, and it is iterating over all the VPCs and subnets and trying to get you a list of all the subnets, and basically the concept of, okay, so coming back to the context is that this is where I am saying that you can do any sort of activity in this business. In this case what I have done, I have iterated over the VPCs, subnets. I am trying to fetch how many used IPs are there, what is the use percentage, what is the status, whether I have any IP available or not. So this is very important also. For example, this one use case where, for example, your client might need a report of whether all my subnets have available IP ranges or not, so as to avoid an unexpected surprise that when they are trying to provision a VM in a subnet, it is showing that IPs are not available. So for example, you can have some sort of a report like this. You can have some sort of a backup report across all your AWS instances also. So the concept is the same. Okay, the concept has no problem. Now here one of the interesting things that I want to show is that when I am calling this use STS role, so this is an AWS, obviously this is also an AWS API call, so this will obviously also need an access key ID or a secret key ID. Now why this was not needed in the code that was shown in the Amazon documentation was because they were calling the code from the context of an EC2 instance, meaning the instance profile was already attached to the EC2 instance, so you don't need to mention anything. AWS automatically takes the instance profile from the instance metadata. But in case you are running it from, for example, a VM which is not an AWS EC2 VM or an on-premise jump box, then what you can do, you can add, if you remember, the CMDB application role, which is basically the role which is only the STS assume role permission, nothing else. Now you go and to the main account, which is the pair account or the master account, whatever you want to call, you create a IAM user in that account. In that IAM user, you attach the role, which is the role which gives the permission to assume all the child roles, and you generate an access key and secret key. Using that access key and secret key, just like this, basically you create, for example, a profile, and then in using that profile you call the main API, which is the assume role API. So the assume role API will run in the context of the pair account, right? So it needs the access key and secret key or the EC2 instance profile of the paired account. Once it is done, it will generate temporary credentials. As soon as you get the temporary credentials, you are running in the context of the child account. So if you understand this concept very clearly, then you will be always okay. Another concept that is not mentioned in the AWS documentation, that is also very important, is that for cross account roles, in the principle of the role, you must mention the user which can access this role, meaning the account ID. So for example, in this documentation, you have to mention when you are creating this child role, okay, this role. So in this role, you must mention that this role can only be accessed by the user or the account which is the pair account, meaning this account. So in this case, what will happen, your security will increase, meaning this account will not be able to be assumed by anyone else other than the paired account, which is missing here in this documentation. So if you add that layer, so even though this paired account can assume all the roles, this cross account role will only allow it to be assumed by the paired account. Similarly, in the pair account role, if you see this pair account role, it is showing STS assume role, right? In this case also, you can give as a resource the actual ARN of these roles, which is again giving the principle of least privileges, meaning you are only giving access that you need, you are not giving anything else. So in this case, what I will write that my resource where I want to assume the role. So for example, if I take this part, okay, and I come here, so here I will write STM assume role, and resource will be this, resource will be this. So what this will do, this is effectively locking down my permissions much more. So in this case, they have kept it simple. They have kept the assume role also. Anybody can, so this or the main pair account or the context of the main pair account can assume any role. I am suggesting to filter it more. It can only assume roles in this child account, not anything else. Similarly, in the child account here, if you see the child account here, there is no mention of who can assume this role. So here similarly, what I am suggesting is that when you will create this role, you will add as a principal you will add the main account, which is the pair account or the master account. So this will further lock it down, meaning only the master account can assume this role. No other account will be able to assume this role in the child account. So this is it. Hopefully this is a little bit clearer now than it was to me when I just read the documentation. I have the code with me. It is openly available. If any of you want to implement this and you have any issues, let me know. So don't forget to share your feedback in the comment sections if any. Thank you.